Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating debate. Is software abstraction killing civilization? A provocative claim, wouldn't you say? A bit dramatic, perhaps?
Absolutely. It's a bold statement. The article we're discussing takes on Jonathan Blow's argument that increasing abstraction in software is leading to a loss of crucial knowledge, and ultimately, the potential collapse of civilization. Intriguing, to say the least.
Exactly. The author agrees with Blow's core point about the importance of intergenerational knowledge transfer, but he meticulously dissects Blow's claims, pointing out numerous inaccuracies and misconceptions. It's a fantastic takedown.
He challenges Blow's assertion that the 5 nines uptime metric is a lost art. The author argues that this metric was never really applied to consumer products like laptops, as Blow suggests. It's primarily used in critical infrastructure, right?
Precisely. And he provides counterexamples, citing companies like IBM and Amazon that still offer systems with incredibly high uptime. He even shows a screenshot of his own laptop boasting a 55-day uptime. A personal touch. I like it.
I see. And what about Blow's claim that the tech industry has stopped pushing technological boundaries?
The author acknowledges that there's a lot of focus on less innovative, money-driven ventures, but he counters that significant advancements continue in areas like file systems, databases, and programming languages. He even mentions the rise of Rust, a language explicitly designed for robustness and low-level control.
That's a good point. Blow also argues that abstraction leads to a loss of capability, focusing on the importance of understanding low-level programming concepts like pointers and memory management. What's the author's response to that?
The author agrees that this knowledge is valuable, but he argues that the number of programmers proficient in C and assembly language is actually increasing. He cites examples like the continued development of Linux and the popularity of CS50, a widely accessible introductory computer science course that covers these topics. A strong counterargument, I think.
Interesting. So, it's not necessarily about the absence of low-level knowledge, but perhaps the accessibility of it? The author also challenges Blow's assessment of programmer productivity at companies like Facebook, right?
Yes. Blow suggests that the massive increase in Facebook's workforce hasn't translated into a proportional increase in new features, implying low productivity. But the author points out that Facebook's core product isn't just the social platform. It's the ad delivery system. A lot of unseen work goes into that.
That's a crucial distinction. The author also addresses Blow's reference to Ken Thompson's 3-week Unix, right? A classic anecdote often used to illustrate the supposed higher productivity of programmers in the past.
Yes, he acknowledges Thompson's achievement, but highlights the vastly different working conditions and expectations of today's developers. No daily stand-ups, no code reviews, no A/B testing back then. He also points out that even in the past, many large projects faced significant delays and cost overruns.
A very insightful point. The author then tackles Blow's claim that software robustness and productivity are declining. What's his counterargument?
He argues the opposite. That computers and software are significantly more robust today. He uses the example of modern operating systems, with features like memory protection and journaling file systems, contrasting them with the instability of older systems, where a simple crash could corrupt entire hard drives. A compelling argument.
He also discusses Blow's assertion that we've lost the ability to easily copy programs between different computer systems. What's his take on that?
He acknowledges that it's not as simple as it used to be, but he argues that this is partly due to increased complexity and the need for installation processes. He points out that even older games often required multiple disks or complex loading procedures. It wasn't always as straightforward as Blow makes it seem.
The author also addresses Blow's concerns about the Language Server Protocol, LSP, and the impact of abstractions on full-screen gaming performance, right?
Yes, he largely agrees with Blow's concerns about LSP potentially hindering deeper understanding. But he also points out that many editors still offer optional LSP support. Regarding gaming performance, he acknowledges that there are issues with input lag and poor performance in some modern applications. But he argues that this is often due to poor coding practices rather than abstraction itself. A nuanced perspective.
And finally, the author addresses Blow's concerns about the loss of deep knowledge in favor of superficial understanding. What's his conclusion?
He agrees that the rapid pace of change in software and hardware can make it difficult to keep up, But he argues that this is more of a problem with the constant churn and release cycles than with abstraction itself. He also emphasizes the importance of maintaining a strong base of low-level expertise to ensure the continued functioning of critical systems. A balanced and well-reasoned conclusion.
So the article presents a compelling counterpoint to Blow's rather alarmist view. It's not a simple rejection, but a careful examination of his arguments, highlighting both their strengths and weaknesses.
Exactly. It's a thoughtful and well-researched piece that encourages a more nuanced understanding of the complexities of software development and its impact on society. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and goodbye.
Bye-bye.